Latest edition of the Reimagining Mobility Podcast series. I'm here with John Kasab. John is a technical expert in fuel cells. John, tell us a little bit. Fuel cells been coming and going for the last, I don't know, some people tell me almost 50 years. I don't think it's quite that long.
No, it's 50
Maybe
years.
It is. Okay, well, So there you go.
So I'll say it's been a long running joke for over 50 years that fuel cells have only been 5 years away from production. And what I can tell you is that in the 17 years or so that I've been working in the fuel cell space, products are actually here now. So it's actually arrived, right? You can actually go, you can order something with a fuel cell in it. It will show up in a reasonable amount of time. So as someone who's been working in this space as a consultant, it's a very exciting time right now.
Good. So is it now also to stay, you think? Or is it, we have something now, but maybe it goes away again before it really comes back full storm? I mean, with EVs, we've had that, right, over the years. What is your take on that?
I would say that it feels like it's definitely going to be it's certainly in the vehicle space, part of the light duty and heavy duty world going forward. Fuel cells have certain advantages over battery only vehicles, for sure, but it adds some complexity, right? To have the fuel cell system, to have the hydrogen fueling system on a vehicle. So it may not be the right mix for all light duty vehicles, for example, going forward, right?
Yeah.
I don't know. So for us at AVL, it's actually a very exciting time because there are lots of options in play right now, and there isn't yet a convergence on a single best solution the way there had been earlier convergence on internal combustion engines, for example. And so it's a very unsettling time in some ways. But again, as somebody who works in the space as an engineer, I think it's great. Lots of stuff going on.
Yeah, uncertainty always demands for a solution, and that's what engineers are for. Yeah,
exactly.
So if you had to take, let's say, the top 3 challenges with, let's just put it this way, making fuel cells on a cost parity with diesel. Let's not go with EVs, but with diesel.
Okay.
What still has to happen?
Yeah, I would say certainly one part of the picture is that as production volumes increase, right, that will help bring down costs of the fuel cell systems and all of the other, kind of vehicle level components. But fuel cell EVs leverage a lot of the existing EV infrastructure, right? So you still have an e-axle or similar electric machine for traction motors. You do still need some battery capacity. Obviously not as big a pack as if it's battery only, but they all have a battery pack on them. Similar power electronics. So the fuel cell vehicle space is certainly able to leverage what's going on in the broader EV world. The second big challenge really has to do with the on-vehicle hydrogen storage. So right now, the best solution is nominally 700 bar pressure vessels. And there's been a move, the carbon fiber composites. It's not really a technology where the costs come down a lot as the production volumes increase, unfortunately. So I know that's an area of active research to try to find something that has better energy storage density. And then the third is kind of the related infrastructure question. There's one part, where does the hydrogen come from? How do we make sure that that's a sustainable fuel rather than having it come from fossil fuels? And then also, how can we make sure that if you have a fuel cell vehicle, you can actually go and refill it, right? So here in Michigan where we are, there aren't fueling stations. So you would get like 300 miles out of your Toyota Mirai, and then you're kind of stuck until you can, arrange for more fuel. But in California, I know I've been looking at our California Tech Center, there are like 3 or 4 hydrogen fueling stations all close enough by
relatively
where
close,
you could easily have a vehicle there and not worry about it too much.
Right. Do you see it? Let's talk about stationary power for a moment, right?
Sure.
Do you see an advantage for the fuel cell technology for the medium and heavy duty truck space? Because volumes or adaptation or necessary technologies, et cetera, can be shared between the transportation space and the stationary power space?
Yeah, I mean,
Or is it two separate and you can't really? Yeah, they need a stack. They need hydrogen, but that's when it ends and everything is off. I don't know. I'm just
So for stationary power, it's reliability and uptime, right? Especially if it's your primary source of power, and then you're effectively using the grid as your backup. There have been systems for sale for a while that take that approach. But it's more akin to like heavy duty vehicle applications in terms of the number of operating hours that are necessary, right? So for trucks, we've been talking like 30,000 hour lifetime. I think for marine and locomotive applications, we're looking at 40 to 50,000 hours. And that's really more where I would want stationary power to be. It's 8,500 to not quite 9,000 hours a year if it's round the clock, right? And so if you want 5 years, that's effectively 45,000 hours operating life. So it needs to be that reliable. Now for stationary systems, certainly people have been looking at PEM to leverage the advances there. But there's a high temperature fuel cell technology called solid oxide. And one of the big advantages of solid oxide systems is that they're more fuel flexible. So you can start with something like natural gas because the oxygen comes across to where the fuel is. So you can oxidize carbon monoxide to carbon dioxide in addition to hydrogen to water and make energy out of that. And so when we're thinking of stationary applications, I would tend to think solid oxide systems rather than PEM.
Okay. But do you see PEM more than on the transportation side?
Yeah. It's lower temperature. It starts up faster. It has a better profile for mobile applications for sure.
So for some of the applications, I've talked to people and they gave me this, I don't know, it's not quite doomsday scenario, but scenario of a truck is at a trucking stop. He or she has the fuel cell running because it's cold and they wanna stay warm. So the fuel cell engine is running. It's generating water. And in the morning when he or she wants to get out of the truck, can't because there's just ice everywhere. What? Reality or just somebody making up something? Or truth is somewhere in the middle?
I guess I haven't really thought through that scenario. I know PEM fuel cells generate a lot of water, right? That is the main thing. And with trucks, you wouldn't even necessarily want to route the exhaust. Well, okay, let me think about that again. So with trucks especially, you would need a water trap in the exhaust to manage that. But yeah, I guess there is a risk that you could end up with it icing up under the truck. I hadn't really thought about that before.
And it was just an interesting comment. I'm like, and I mean, I know a little bit enough to be dangerous in fuel cells. And then when I thought about it, I was like, that truck is essentially, I've seen them at rest areas, right? They run, quote unquote, all night because of the mandatory rest time, whatever, right? So, but it runs, and again, if you're in let's say Michigan in the winter and it's cold, it's 10 degrees, that thing runs, has to warm up, generates water.
Absolutely. And I think this gets to where it would be a hybridized powertrain. So one thing you could do is, instead of running the fuel cell overnight, where you're using, like a 300 kilowatt power plant to generate the 10 kilowatts of hotel load that are needed, use the battery pack instead to manage your overnight hotel loads. And so then you're not generating all that water. Or if the fuel cell does need to spin up to kind of charge the batteries up overnight, it can do that without shaking the cab, right? Fuel cells are very quiet. It's just compressor noise primarily. So it's a thing where it could start and then go through its full freeze cycle. So it might not have to run overnight and be generating all that water while the truck is just sitting there. So that's probably how I would manage it from a controls point of view.
Engineering on the fly right
here.
MTI specialty, that's good. If you look at cost, I hear a lot of people saying, yeah, fuel cell, no, we believe it's here. There are some application, but boy, it's just so cost prohibitive.
Yeah.
And man, it's just like almost like a hybrid vehicle, right? Between a battery electric system and a diesel or gasoline engine system. So a traditional hybrid. It is a hybrid, true. It is probably more complex than a pure BEV. But what do you see from a cost parity? Is it sure there is right now a discrepancy, but we see in X years that this is at parity, and then, or how do you see it?
Yeah, for sure. I mean, I would say our internal AVL analysis is that fuel cell stack and system costs will come down pretty significantly, especially as the volumes increase. I would say that the Department of Energy regularly funds cost analyses, and it's the same story. There are certain fixed costs with the materials that are hard to get around. Platinum costs what it costs. And so the big challenge is, well, how can I make my fuel cell PEM stack durable over the life I want, maybe with using less platinum at the beginning, so I still have the right end of life performance, right? And I know GM, for example, has been doing a lot of work in that area to try to get the amount of platinum. I'd heard for their light duty system maybe comparable to what's in a 3-way cap. Okay. So in terms of a first cost, I think there is a pathway to getting something that's comparable, especially if you think of, say, with heavy duty vehicles, a diesel engine with all the after treatment that's required, especially to meet ultra low NOx requirements, right? There are no criteria pollutant emissions from a fuel cell EV powertrain. So you've simplified your life tremendously that way. The other part of the picture, though, of course, is the fuel cost. And, again, DOE has shown that there are pathways to getting hydrogen fuel at something in the $3 to $5 per kilogram, which is roughly a gallon of gasoline equivalent range, but it's nowhere near that now. And I would say that is going to continue to be a barrier to adoption, except in areas where it's almost required based on local emissions regs.
And you see the barrier from a fuel cost perspective. The barrier is in infrastructure, in people willing to invest in production, the government willing to incentivize it.
Yeah. So, I mean, certainly in the U.S., Department of Energy has been very good understanding that it's you have the vehicles and the fueling infrastructure both have to take the step forward together. And so there's certainly a place for government incentives to help that happen. I know in California, the California Energy Commission had committed over $100 million to build out a network of hydrogen fueling stations. So it's not every fueling station, but it's no harder than if you had like a light-duty diesel vehicle, right? You kind of have to know where the stations are, but you're never that far from one. So it's that kind of support from a fueling infrastructure point of view. I think people know what the technology is to get to sustainable hydrogen production, right? So using solar or wind energy, using an electrolyzer to make the hydrogen. It's just expensive to compress hydrogen. It's a small molecule. It doesn't like to get squeezed down to 700 bar for transport. And so that definitely adds to the costs. And it also has to do with how much hydrogen are you dealing with. I mean, hydrogen is produced in large volumes right now, mostly from methane for use in refineries. And so there are places, I'm going to say in like near Rotterdam in the Netherlands, in Houston, where there are hydrogen pipeline networks, because it's used enough regionally where it's worth that investment. Does that mean that there are going to be hydrogen lines to Southeast Michigan or even to Chicago? I don't know.
Not there
so
yet,
there'll still be some amount of local transport that's required that may add to the cost.
Okay. Our strategy or consulting organization put a report together, I think a year or two ago, talking about this cost parity and what it takes from a complete vehicle system, right? So they looked at the cost of the vehicle, the cost of the components, of the technologies in it, and the cost of the fuel that you just mentioned. And I remember reading that and walking away from the report and thinking, there's a lot of assumptions in there, which every report does. But at the end of the day, I felt like there was a lot dependent on government incentivizing it,
Absolutely.
or government punishing with either additional costs or taxes or whatever on somebody that continues to use diesel or gasoline.
Right.
Do you see that as a prohibitor in this country, where we're less maybe focused on punishing other users, at least more or less until now?
Yeah.
Versus Europe, that is much more willing to use that, let's say, that instrument that they have on pushing people into a new direction, into a new technology.
I'm going to take that in two parts, right? So in the light duty market, where in the US it's almost all gasoline fueled vehicles right now. I mean, they're obviously EVs, but gasoline fueled. I think it may be easier to create incentives in the way that California has started to do, right? Looking ahead to their 2035 deadline, effectively. And there are several other states that have already announced they're going to follow California's lead. So that is going to create a strong regulatory incentive to look at other options. And it feels like there are enough other options that are kind of ready to go, where that transition might be smoother. And it, 13 years is both a long time and not that long at all. I mean, it's effectively 2 product cycles in the light duty business, right? The challenge as you start getting to heavy duty is that diesel really makes the economy go right now. And it's a very energy dense fuel. There's an existing network for it. And I think it's going to be slower to provide that kind of incentive to transition everyone over. But I know people are thinking about it, right? I've seen at a conference earlier this year in marine applications, people are beginning to look at, even leaving aside transitioning from bunker fuel to diesel, moving from diesel to some other kind of combustion fuel that would have a lower CO2 emissions impact. Certainly in the trucking world, there have been lots of announcements and partnerships announced over the last few years to kind of look at that transition as well. I'd say more so in Europe than here, but there's been a lot of interest in hydrogen-fueled internal combustion engines, especially for heavy-duty applications. I see that as kind of a transitional technology approach, but it would help create demand for the fueling infrastructure. So I think it's going to be slower, but also people hang on to commercial vehicles and for a lot longer, and like locomotives have a 50-year life, right? So it's not, even if 2035 was a hard stop, there are going to be lots of diesel locomotives on the rails for decades to come, right? But I think it's worth looking at, and I know CARB does this, I'm sure EPA does as well, like, well, what are the major contributors? And let's work on those, let's squeeze those down first, right? And then we can, when things like locomotives start to become a large piece of the carbon pie, then we can, bring our attention to that instead.
Right. Okay, last question. So you've been involved in fuel cells, like you said, for many, many years.
Yeah.
What's the most exciting thing you look forward to in 5 years related to fuel cell technology?
Oh, yeah. So I would say kind of the continued development of fuel cell powertrains and getting them integrated into vehicles, and really starting to get the technology into like real people's hands so you can see it, right? I'm just thinking of like the Ford F-150 Lightning, they literally cannot make them fast enough, right? People are just very excited about them. And I think Ford been very pleasantly surprised with the demand. Probably unpleasantly surprised because they aren't prepared to handle it, right? And so I'm thinking that, there are just a lot of potential advantages of fuel cell vehicles. I mean, I'm just thinking, for example, with transit buses, right? One of the issues is occasionally buses have to idle at the end of the line, and they have a diesel engine in them. And so it's just kind of like rattling there, for some minutes before it turns around and does its return route. Like, well, fuel cell vehicles are silent and are much quieter than diesels, right?
Yeah.
And you have this option of, well, you could put it into a battery-only mode for a bit if you didn't have a large power demand from needing to run the AC or something like that. And I think for urban environments, that is potentially a much friendlier application, just from a noise profile point of view, even leaving aside the benefits to criteria pollutant emissions and so forth.
Yeah. Okay.
Yeah, but it like I said at the beginning, I'd say one of the really exciting things is that the real products, and so we're really moving from pre-development into product development type of activities.
Sure.
And so that puts it into a much more exciting world from an engineering point of view.
I can feel your excitement. Very good.
Good.
Thanks, John, for your time.
Yeah, my pleasure.
And thanks for tuning in.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.